Cindy here. Let's take a look at addition and subtraction formulas in section 7.2 of grade 12 advanced functions. Woo! So before I start getting into everything, I just want to let you guys know that if you haven't done your homework already, you should probably do that. I probably sound like a teacher. I know you're probably tired of people nagging on for you to do your homework, but I'll be honest, for a unit like trig, if you don't do your homework, if you don't practice enough, you're never going to get it. So yeah, and plus it'll make a lot more sense. So please use this video as a last resort if you absolutely do not get it at all. So yeah, so first, these are the addition and subtraction formulas that we learn in this unit. Honestly, your best bet is just to memorize them. You can memorize them any way you can. How I memorized it, I just wrote it down a bunch of times until it just stayed in my head. But obviously, many people have their own ways of memorization. What works for me might not work for you. So a trick that my tutor taught me for memorizing addition and subtraction formulas is to think about sine, cos, and tan as good guys and bad guys. So what do I mean by that? Well, first, if you notice in both the addition and subtraction formulas, they all have the same structure, right? Sine A, cos B, cos A, sine B, cos A, cos B, sine A, sine B, blah, 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 blah. The only difference between the addition formulas and subtraction formulas is the signs in between them. So how are you supposed to memorize all the signs? Well, this is where good guy, bad guy comes in. So the reason why sine is known as the good guy is because, let's say in an addition formula, they give you a plus, and in the equivalent formula, it's also a plus. So these two signs agree with each other. That's why it's a good guy. Cos, on the other hand, you're given a plus, but then you end up with a negative. So the two signs do not agree with each other, and that's why they are the bad guys. So tan is kind of different because tan is known as the double agent. Tan is the double agent because, let's say you're given something as a plus, and it agrees with you. The sign agrees with you in the numerator. However, in the denominator, it's the opposite sign, and that's why it's a double agent. So yeah, if you can memorize the double agent, good guy, bad guy way, that might help you memorize it if you're having trouble. But if you memorize those, then I guess we can get started onto some examples. So I'll actually start with number 2 first. So the great thing about number 2 is that if you took the time to really memorize these formulas, it becomes really easy to solve this question because you'll be able to recognize the structure really quickly. Because if you look over here, isn't this thing basically the same as this? Except instead of A and B, you have actual degrees. And even though we work in radians, I just ignore that question for now. I just took it from the homework. So if we were to rewrite this whole entire thing, then this would just easily be tan 40 degrees plus 50 degrees, following the addition formula. And then you just add them up. So that gives you 90 degrees. And look, 90 degrees is great because it's a degree that we've worked in before. And we could turn that into a radian that we've worked before. So tan pi over 2. And so now, because it's asking us to evaluate the following, we're just going to draw our cast diagram. A really bad one. So realistically, your diagram is supposed to look like this, but for visualization purposes, we're going to draw it out as a triangle. So we know that the angle over here is pi over 2. And because this is what it actually looks like, we know that the hypotenuse is the same length as the height. And so the base is 0, if that's the case. And if you remember the definition of tan theta, it's y over x. And so if we were to do tan pi over 2, y, so 1, over x, it's 0. But then because it's all over 0, that means it's undefined. And so our answer for this particular question is equal to undefined. So yeah, that's a great part. If you memorize it, you can instantly recognize these structures and you'll be able to do these questions really fast. But if you were to get a question such as this or this, it'll be a lot harder to recognize anything. And so that's why there are 2 different ways that you can approach questions such as sine pi over 12. So you can see this as both a double angle question or an addition or subtraction question. Personally, I find breaking this down into addition and subtraction is much easier than using double angles. Only because there's just a lot more thinking involved for double angles. But yeah. So because we know that pi over 12 is something we never worked with in terms of special angles, we're just going to break it down into 2 parts. So if you agree with me, pi over 12 is the same as 1 over 12. If you agree with me on that part, we're going to break this down. We're going to break pi over 12 down into 2 different parts, okay? So we're going to try 3 pi over 12 minus 2 pi over 12 gives us pi over 12. If you agree with me on that, then that's great. We can move forward because, 3 minus 2 gives you 1. So if we were to simplify and reduce this down even further, we get pi over 4 minus pi over 6. And because we know because these are two special angles that we worked with and we know how to deal with it, we are going to use these angles instead of pi over 12. Alright, great. So now we're just going to pretend this is A and this is B respectively. We're just going to plug these into the formula. So sine pi over 4 cos pi over 6 minus, because it's a good guy, and then cos pi over 4 sine pi over 6. So now that we wrote it down in the formula, using our knowledge of special triangles and the cast rule, we can easily figure out their exact values. I'm going to assume that you guys know how to do that, because I'm too lazy to do that over here, so we'll just do that. 3 over 2 minus 1 over root 2, and then 1 over 2. So now that we have the exact values, we're just going to expand and simplify it. So that gives us root 3 over 2 root 2 minus 1 over 2 root 2. Because they have the same common denominator, we can easily write this as root 3 over minus 1 and 2 root 2. So you can leave your answer like this depending on your teacher, but if your teacher wants you to rationalize the denominator, don't forget to do that. So just simply multiply it by root 2, and then you will get your final answer as root 6 minus root 2 over 4. And that's how you solve questions like this. Just break it down. So now that we know how to do 1, I'm going to let you guys do 3 for yourselves. If you don't know how to approach this question, remember I said break it down. So this is just a bit of a little boost for you to do. So you can break this down into pi plus pi over 12. And pi over 12 can be further broken down into pi over 4 minus pi over 6. These are A and B respectively, so if you were to plug it into your cos equation, your addition cos equation, you'll get something like this. And then the thing is, for these questions, you have to break it down even more, so then you'll get into like cos pi over 4, cos pi over 6 minus sine pi over 4 sine pi over 6. And same on the sine 2, you'll like end up breaking down even more. So yeah. Don't be afraid to break things down. That's the best way that I find to do it. It does take a long time, but if you get the hang of it and if you find that this method works for you, then go ahead and use it. Anyways, I hope this makes sense.